So very warm welcome students. So today we are going to see about the feed forward neural networks that represents a function of its input. So in the feed forward neural networks we are having three inputs such as 3, 4 and 5 and 1, 2. So 1, 2, 3, 4 and 5. So when we go from 1 to 3 we have weighted of 1, 3 and 2 we have weighted of 2, 3 and 3 we have weighted of 3, 4 and 4 we have 4, 5 and when we go for the another one from 2 to 3 we have W2, 3. So this is about the representations of the feed forward neural networks in its type of input. So we have two inputs here and the two inputs is connected with various number of outputs here. So when we go for that we have an additional thing which is very essential for that is one output. From the two inputs we can get one output. Okay, next one. So two hidden inputs are also present in the feed forward neural networks. The bias is present in such a way that it is of simplicity and each unit receives only one input from the units in the immediately preceding layer. Given an input vector x of x, x1, x2, the activation of these are set to the values of the input vector and the network outputs. And the next one is A5 equal to G of W35.A3 plus W45.A4. So this is some of the parameters of the functions. So this is about adjusting feed forward neural network computizes the parameterized family functions. By adjusting the weights we get different functions. That is how learning is done in neural networks. So next one is we are going to see about perceptron. See, one of the most common and influential neural networks in the perceptron. It is an important milestone in AI. So it was invented by Frank Rosenblatt in 1957 in an attempt to understand a human memory, learning and cognitive processes. And the first neural networks modeled by computation with remarkable learning algorithm. Its function can be represented by perceptron and the learning algorithm is guaranteed quickly to converge them to the hidden functions. And when we take about the perceptron, the most beautiful thing in the perceptron is the hidden layer and the research layer that is used for. So this was Rosenblatt Mark I that is used for perceptrons identification. So the Rosenblatt's psychological review, the probabilistic model for information storage and organization in the brain. The psychological review volume 65 number 6 pp 386-408 November 15 1958. So this is single layer feed forward neural network perceptrons with input and output units. A network with all inputs connected directly to the outputs. The outputs units are all operate separately, no shared weights. And each unit output has its independence of others, which can limit our study to output. So this is perceptron to learn identify digits which have 0, 1, 2, 3, 4 and 5, 6, 7, 8, 9. And this is 7 segments that is been present to produce the 10 digits. So 10 digits starts from 0, 9, 0, 9 and 8, 7, 6, 5, 4, 3, 2, 1, which consists of 0, 1, 1, 0, 1, 1, 1, 1, 0. So this is another perceptron model. The perceptron model comprises of varieties of things that is being present actually. So this is single layer feed forward neural networks that comprises of two input layer perceptron with sigmoid activation function and the adjusting weights that moves the locations and the orientations of the cliff. And this is perceptron learning intuition, which consists of single output, target output and T. Consider some initial weights that differs with the errors and move such words in a right direction. If the error is positive, we need to increase 0. So this error greater than 0 need to increase the 0. Error less than 0 we have to decrease the O. In each input j we contribute j, 1 to total input in such a way that if I1 is positive increase W1 tends to increase 0, 1. If I1 is negative increasing tends to increase 0. So use this function. Perceptron learning rule by Rosenblatt 1960 is a so you have to consider adapted from the Patrick Vincent book framework and notation 0 bar 1 signals learning rate equal to 1. So the input vector is such a way that x is equals to x0, x1, x2, x7 with input factor with W0, W1, W2, Wn. And this is some of the perceptron functions. 0 of 1 equal to theta equal to minus 0 stimulate the threshold value, whereas the learning rate equal to 1. So the output is 0 and with 0 or 1 as the single output. So this is a threshold functions. So 0 is greater than 0, then else 0 equal to theta. So this is about the perceptron learning examples along with the usages. So thank you all.